Hello and welcome. In this video we're looking at the June 2018 AQA GCSE Maths Higher Paper number 2. We're going to look at questions from 11 through to 20, which are worth a total of 28 marks. Question number 11. Two ordinary dice are rolled. Complete the tree diagram. So we've got the first dice, so you've got the probability that it's less than 3, and then the probability that it's 3 or more. So you must remember that all probabilities add up to 1, so each branch will need to add up to 1. So if we've got 1/3 on this side, we need to have 2/3 on this side. Again, 1/3 here, so 2/3 here, so the branch adds up to 1. Now this one's got no numbers here, but we are told that they are fair dice. So the probability should be the same. So the probability of the first dice and the second dice should be exactly the same. So less than 3 should be 1/3, and 3 or more should be 2/3. That will get you the mark for part A of the question. Part B. Work out the probability that both dice lie on a number less than 3. So we are looking at this path. The first one has to be less than 3 and the second one has to be less than 3. So we look at the probabilities here. It's 1/3 and 1/3. Now the word "and" in probability means times. So it's 1/3 times 1/3, which is 1/9. So the probability that both dice lie on a number less than 3 is 1/9. Part C. Work out the probability that exactly one of the dice lands on a number less than 3. So this means either the first one lands on a number less than 3 or the second one lands on a number less than 3, but not both. So let's look at the example where the first one lands on a number less than 3. So that would mean that the first dice would have to be there, and then the second dice cannot be there, it has to be here. So this is our first probability. So this will be 1/3. So the first one has to be less than 3 and the second one has to be 3 or more. So 1/3 times 2/3. Is there another way of doing this? Yes, the first one could be more than 3 or more. And then the second one would then have to be less than 3. So this would be 2/3 multiplied by 1/3. So 1/3 times 2/3 is 2/9, and 2/3 times 1/3 is also 2/9. Now we can either have this outcome or this outcome, and the word "or" in probability means add. So we're going to do 2/9 add 2/9, which gives us 4/9. Question number 12. A straight line is drawn on a centimetre grid. Faye assumes that the scale is 1 centimetre and represents 1 unit. Use her assumption to work out the gradient of the line. So we need to draw a triangle, and it's best to make your triangle as big as possible. So gradient is equal to the rise divided by the run, or change in the y divided by the change in the x. So the change in y is 1, 2, 3, 4 squares, and we're told that 1 centimetre is 1 unit, so 4 squares is 4 centimetres, and along the x-axis we've got 8 squares. 8 squares. So the change in y is 4, the change in x is 8, so the gradient is a half. The gradient of the line is a half. 12b. In fact, the scale is 1 centimetre represents 2 units. Which statement is correct? Take one box. The answer is too big, the answer stays the same, or the answer is too small. So this is your centimetre grid. So 4 centimetres here represented 4 units. But we're told that 1 centimetre represents 2 units. So 4 centimetres will now represent 8, and 8 centimeters will now represent 16. So let's look at what the gradient would be now. So change in y divided by change in x. So the change in y, 4 centimeters, which is 8 units now, and 8 centimeters, which is now 16. So 8 over 16, this will simplify to a half. So our gradient stays exactly the same. Question 13. Show that for x is not equal to minus 1, 8x squared minus 8 over 4x plus 4 simplifies to this form where a and b are integers. So we need to be simplifying here. Let me write the question out again. So 8x squared minus 8 over 4x plus 4. So let's take out any common factors. So first of all, we have an 8 as a common factor on the top, leaving me with x squared minus 1. And on the bottom, we have a common factor of 4, leaving me with x plus 1 inside the bracket. Can we simplify any further? Yes, x squared minus 1 is the difference of two squares. So this can simplify to x plus 1 and x minus 1. And then the bottom, 4 bracket x plus 1. Now let's simplify this as much as possible. So the x plus 1 cancels with this x plus 1. Now we have an 8 and a 4, so we can divide both top and bottom by 4. So that would cancel out, leaving me with just a 1. That would cancel out, leaving me with a 2. So I'm now left with 2 on the top, bracket x minus 1, and on the bottom it's just 1. So this is what I'm left with. But the question says give your answer in this form, so I just need to multiply out the bracket to give me 2x minus 2. Question 14. The scale drawing represents a garden. Water from a sprinkler at P reaches 20 meters from P. Water from a sprinkler at Q reaches 25 meters from Q. Using a pair of compasses, show the region that both sprinklers reach. So the scale here is 1 centimeter is 5 meters. So we're told this is 20 meters. So in terms of our scale, 20 meters is going to represent 4 centimeters, and 25 meters is going to be 5 centimeters. So the sprinkler from P is here, reaches 20 meters. So obviously you'd need to use a pair of compasses here. I'm going to do the best I can with my pen here. So 4 centimeters will be 4 squares. So it's going to reach 4 squares in this direction, 4 squares in this direction, 4 squares in this direction, and 4 in this direction. And then you just place your compass here and you draw yourself an arc. And then the sprinkler reaches 5 centimeters from Q. So Q is here, so we need to reach 5 centimeters in each direction. Okay, and we get our compass and we try to do that. Hopefully with the compass you'll do a lot better than I have. Show the region that water from both sprinklers can reach. So that's just this overlap area here. Okay, so just make sure you shade that in your diagram. And make sure you use a pair of compasses. Question 15. 100 men and 100 women took a test. Using the data, which statement must be true? Tick one box. So men had a higher average score than women, men had more consistent scores than women, a woman had the highest score and a man had the lowest score. So let's see what information we are given. So we're given the median, which is an average. We are given the range, which is a measure of spread of data, and we're given the interquartile range, which is also a measure of the spread of data. So let's see which of these are definitely wrong. Men had a higher average score than women. Men had a median of 28 and women had a median of 30. So this one's unlikely, I'm just going to put a little cross there for now, men had more consistent scores. That means that their spread of numbers, the spread of their scores, must be lower. So that means they must have a smaller range and a smaller interquartile range. So the range of men is 31, which is smaller than that, and the interquartile range is 7.5, which is smaller than that. So it looks like this is going to be the right one, but we need to check our other ones. A woman had the highest score. So all we know about women is that they had the higher median and that they had a higher range, but we don't know what the lowest score was and what the highest score was. So we cannot be sure of that. And a man had the lowest score. So same reason, we don't know the lowest score and we don't know the highest score. All we know is the range. So we are not sure about that. So this would have to be the correct answer. Number 16. Some concrete has a volume of 3.8 meters cubed. The density of concrete is 2,400 kilograms per meter cubed. Work out the mass. So this is going to require the density formula. So density, we're working out the mass. So we need to rearrange this formula, multiply both sides by the volume, leaving us with volume times density equals mass. So the volume we know is 3.8, and that's meters cubed. And then the density is 2,400 kilograms per meter cubed. So make sure that those units are the same. So 3.8 multiplied by 2,400. This will give us the mass. So that gives us 9120. Now the units for this will be kilograms. The 3.8 meter cubed of concrete is made into the shape of a cylinder. The base radius is 0.5 meters. Work out the height. Okay, so we are told the volume, we are told the radius, and we need to work out the height of the cylinder. So we're going to start off by writing down the formula for the volume of a cylinder. So the volume of the cylinder is pi r squared multiplied by h. And let's substitute in what we know. So we know that the volume is 3.8 is equal to pi multiplied by r squared, which is 0.5 squared, multiplied by h. Let's rearrange this to get h on its own. So we'll need to divide through by pi times 0.5 squared. 3.8 divided by pi times 0.5 squared. This gives us 4.838. 4.84 meters to three significant figures will be the height of the cylinder. Question number 17. A ball is thrown vertically upwards. The graph shows the height of the ball above the ground after it is thrown. For how many seconds is the ball at a height of more than 2 meters? So it's thrown from a height of 2 meters. It goes higher, it goes over 4 meters, almost 5 meters, then comes back down. And this is the point where it gets to 2 meters high, and then eventually it goes to the ground. So for how many seconds is the ball more than 2? So we start off at 0 seconds, and then we finish at, I'd say, 3 seconds. So 3 take away 0 is 3. So the answer to the question, 3. After how many seconds is the ball at instantaneous rest when it's in the air? So instantaneous rest is the point where it's initially going upwards and then is about to start coming downwards. So it almost stops for a split second. And that's basically asking for the highest point on the graph here. And we want to know after how many seconds is the ball at instantaneous rest. So we just need to read off the time from here. Again, just read all the way down. I would say that's 1.5 seconds. And part C for 2 marks. Work out the average speed of the ball when it is moving downwards. So this is the point where it starts to move downwards, and this is the point where it finishes moving downwards. So this goes down from a height of, I would say, 4.6 meters to 0. So the distance is from a height of 4.6 to a height of 0. So the distance traveled is 4.6. And then the time it's taken is from 1.5 seconds to here, which I would say is 3.5. So 3.5, take away 1.5, which is 2. So speed equals distance divided by time. Distance was 4.6, the time is 2, so your speed will be 2.3 meters per second. Question number 18. The solution of 3 to the power of x equals 300 lies between two consecutive integers. Work out the two integers. So an integer here is a whole number. The best way to do this is just a bit of trial and error. So let's start with 3 squared. We know 3 squared is 3 times 3, which is 9. 3 cubed. So 3 times 3 times 3 is 27. Remember, this is a calculator paper, so you can use a calculator for this. 3 to the power of 4. Let's use our calculator for this one. 3 to the power of 4, which is 81. So we're going to keep going until we get past 300. Let's try 3 to the power of 5. Which is 243, so we're getting there. And 3 to the power of 6. $729. So 300 lies between these two numbers. So the answer to 3 to the power of x equals 300 is somewhere between 3 to the power of 5 and 3 to the power of 6. So x must be somewhere between 5 and 6. Question 19. A pentagon is made from a square and an isosceles triangle. Work out the perimeter of the pentagon. Okay, so the perimeter, we need to add up all the sides. So the pentagon has 5 sides. We actually know 3 of them. We know this is 12, this is 12, and this is 12. So what the question is asking us to do is work out these 2 sides. Now this is an isosceles triangle, so we know that the 2 sides are going to be equal. And it's also marked out by this little line here. So I'm going to now split this triangle in half here. Okay, now the triangle on the left I'm going to redraw. So we have this triangle here. What do we know about it? Well, we know that this length here is half of the whole length, and we know the whole length is 12. So this must be 6. We know it's a right angled triangle, and then this angle is one we can work out because that there is 90 degrees, and the whole angle is 125. So the difference between 125 and 90 is 35. So this angle here must be 35. And we're trying to find out the length of this side here for the perimeter. So let's call this x. And this is going to be basic trigonometry. So we need to figure out, is it sin, cos, or tan? So SOHCAHTOA. So let's label our triangle. So we have the hypotenuse here, we have the opposite here, and we have the adjacent here. Does the hypotenuse have a value? Yes, it's x. Does the opposite have a value? No, we don't know anything about the opposite, so we don't underline the O's. Does the adjacent have a value? Yes, we know that's 6. So K has the 2 underlines, so K is short for cos theta equals adjacent divided by hypotenuse. So theta is the angle, so cos 35 is equal to adjacent, which is 6, divided by the hypotenuse, which we've called x. And we need to solve this equation to make x the subject. So let's get rid of the fraction first by multiplying both sides by x. So x times cos 35 is equal to 6. And now we want x on its own, so let's get rid of the cos 35 by dividing by cos 35. So x is equal to 6 divided by cos 35. Let's type this in. 6 and then divided by cos 35. So syntax error, that usually means brackets. Close the bracket. We get 7.32 to 3 significant figures. Okay, so 7.32 is the length over here. Now before we continue, let's just make sure that sounds reasonable. So 7.32. Remember that hypotenuse is the longest side. Based on the information in this triangle, is the hypotenuse the longest side? Yeah, well the only other side we have is 6, and this is definitely bigger than 6. So this seems like a reasonable answer. So we know that that's 7.32, and this triangle is exactly the same, so this triangle will also have the length of 7.32. So now we can work out the perimeter by adding up all of the sides. So that's 12 plus 12 plus 12 plus 7.32 plus 7.32. Alright, I'm going to use the full answer here for 7.32. So I'm going to use that number and I'm going to multiply that by 2, which gives me that. And then I'm going to add the 12, 12 and the 12, which is 36. So I'm going to add 36 to that. And I get 50.65. My units are centimeters. My perimeter is 50.65 centimeters. Question 20. Here is an inflated swimming ring with the dimensions in centimeters. So A is that length there, B is that length there. So the small radius is A, the big radius is B. The volume of the ring is given by this formula. V equals 0.25 pi squared multiplied by B minus A squared multiplied by B plus A. Work out the volume when A is 20 and B is 30. So all this question is asking you to do is substitute in A is 20 and B is 30 into this formula. So we can just go straight into our calculator and do this. Okay, and we should be able to just type the whole thing in. So 0.25 times pi squared. Then we've got brackets B minus A. So B is 30. Okay, so B is 30 and A is 20. So it's 30 minus 20. Close bracket. And then that is squared. And then multiplied by B plus A. So 30 plus 20. Of course, you can work out these things before typing it in. So you could have put 50 and 10 instead of 30 minus 20 and 30 plus 20. Close bracket, press equals, and that's our answer there. 12337. So that's the volume in centimeters cubed. The question says give your answer to 3 significant figures. So 1, 2, 3. The number after that is a 3, which is less than 5. So that stays as it is. So it's 12300 centimeters cubed.